Hello.
Hello.
Hello, hello.
Yes, sir.
You can hear me, right?
Yes, I do.
Okay. Tell me, what are the doubts in that binomial thing first?
Yes, sir. Third one, sir.
Okay. Uh, third one. Third one, as in the document,
No, no, sir. Binomial one is the second one.
to match the following.
Um, Actually, I mean, multiple characters. Third,
Okay. Questions in multiple correct in that which one? Second
third
one.
one. Third one. 1 plus x power 2021.
Hmm. Okay. First and second you got.
Yes, sir.
Okay. Uh, 1 plus x power 2021 is equal to, obviously, C0 plus C1x till 2021, we can write C1x plus C2x square till C2021 x power 2021. And after that, sum of the product of the coefficients taken two at a time, okay, can be represented by this. And you have to find the, okay, you have to find the sum, right? So
Yes.
sum of product of coefficients taken two at a time, is equal to, you can represent it like this. I goes from 0 to 2021. I goes from 0 to 2021, and j is equal to I plus 1 till 2021, right?
Yes.
Cij. Actually, this is easy only. You have to find the value of this, right?
Yes.
Uh, so do you understand the meaning of the summation? Do you understand what this means? Why they have written it like this and all?
No.
Yes, right?
Yeah.
So basically, think about it. If you fix the I is 0, right? Then j can go from 1 to 2021, right?
1 to 2021. Yeah.
So basically, you are saying C0, C1 plus C0, C2, and so on till C0, C2021, right?
Yes.
Correct.
Yeah.
And then you fix the Ci as 1. So C1, C2, C1, C3 till C1 2021, right?
Yes.
And so on. Basically, you are covering each pairs, right? All the pairs.
Yes. Yeah.
Okay. So as soon as you see this, you should get the idea that if I square it, I will get 2 times these pairs, right? Like, do you understand what I'm saying? If I take the square of this, what should you get? We should get the squares, right?
Yes.
And we should get twice of the sum of two at a time, right?
Yeah.
That is the a plus b plus c whole square. That's how it comes. No?
Yes.
So if I need this, I just need to subtract this and this, no?
Yes.
That's over immediately, no?
Oh.
This is 2 power 2021 minus this is 2ncn, right?
Yeah.
So 2 into 2n, n is 2021. So 4042 c 2021, right? Is equal to 2 times double summation, right?
Yes.
So the answer will be 2 power 2020 minus half into 4042 factorial by 2021 factorial square, right?
Yes.
Now you can see which options are fitting and all,
Yeah.
right?
Yes.
It feels like it's obvious alpha is this and all. You can find everything, right?
Yeah.
So the thing is ki as soon as you recognize this is product of two at a time things, you should realize that where else will I get a two at a time? When I square something, I get twice of that two at a time stuff, no?
Yeah, yeah.
And that if you got the idea, that's it's over because we know the sum of this, right?
Yes,
And we know the sum of this, there is no issue, right?
yes, yes.
Okay. What else tell me?
Seventh one.
Multiple correct section only.
Yeah.
Okay. Seventh one. Let an be equal to 2n plus 5. An is equal to 2n plus 5. Bn is equal to 1 by 3 whole power n. N belongs to natural numbers. And then we have to do summation of AK, BK, CK. Okay. If summation of AK, BK, CK. If summation of AK, BK, CK, where K goes from 1 to n, K goes from 1 to n is equal to 1 by 3 n plus 1, n plus 2, n plus 3. N plus 1, n plus 2, n plus 3. Okay, this is said. Then you have to find stuff about Cn, right?
Yes.
Then the options are telling us one is C1 is equal to 1. No, C1 is 24 by 7. Cn is this. Cn is equal to basically n plus 1, n plus 2, 3 power n by 2n plus 5. N plus 1, n plus 2, 3 power n by 2n plus 5. This is for n greater than equal to 2. For all n greater than equal to 2. And the third one is sum of reciprocals of Cn. Sum of reciprocals of Cn from 1 to infinity is 29 by 72. N is equal to 1 to infinity is 29 by 72. And the fourth option is limit of n tends to infinity, 1 by Cn is 0. Okay. 1 by Cn is 0. Okay. So we have to somehow get a sense of how to calculate. They have given us this data, right? So first of all, I have to find C1, right? I will take n is equal to 1, obviously, right? Correct. N can be any natural number. The first natural number it can be is 1, right? So then this summation will be some single term, right?
Yes.
This summation will be A1, B1, C1, right? Will be equal
Yes.
to 1 by 3, 1 plus 1, 2, 1 plus 2, 3, and 4, right? So this is 8, right? And when n is 1, this is 7, right? And when n is 1, this is 1 by 3. And C1 is 8, right? So it is clear C1 is 24 by 7 is coming, obviously. Correct? Did you get 24 by 7 C1? So that's because you are not thinking. See, you have to find so much information about Cn. They have not given you anything about Cn, right?
Yes.
That means obviously you have to use this somehow, no?
Yeah.
How can you use it somehow? If you don't know anything about Cn, can you do any standard method? It's not possible, right?
You just put it as one.
You will have to put it and see, something. Because is there any standard method possible to sum it when you don't even know what Ck looks like?
Yes.
There is no way you can do anything, right?
Yeah.
Do you understand what I'm saying?
Yes.
So you have to put some values and check. Otherwise, there is no option for you to do anything, right?
Yes.
So C1 we have gotten is 24 by 7. Now also we have to still find Cn somehow, right?
Yeah.
Okay. Cn we have to find. So first of all, I will check for 1 is the formula giving me 24 by 7 here, right? Correct. So you'll get put n is equal to 1 here, 2 into 3 6 by 7 and 3 power 1. 6 into 3, right? 18. Okay, this formula is supposed to be true only for n greater than 2, right? So this formula may not work for 1. It's fine. Do you understand what I'm saying?
Yes.
This formula is not right now working, but because we have taken only 1. So let's find C2 then, right? Correct?
Yes.
C2, finding C2 is also obvious, no? N is equal to 2, right? Put n is equal to 2, you will get 2 terms, right?
Yes.
So if I do put n is equal to 2, what is this summation this side? It is A1, B1, C1 plus A2, B2, C2, right? And this side becomes n is equal to 2. This is 3, 4, 5. So this cancels 4 into 5, 20, right?
Yes.
And A1, B1, C1 will become, when you put n is 1, no, A1, B1, C1 was basically, it was 7 into 1 by 3 into 24 by 7, right?
Yes.
Plus A2 is what? 9 into 1 by 9 into C2, right?
Yes.
Correct? So this
Yeah.
becomes 8. This becomes C2. See, C2 is 12 is coming, right? Correct?
Yeah.
C2 is 12. And now we'll check for n is equal to 2 here in this formula, right? N is equal to 2. This will become 3 and 4 by 9 and 3 power 2, right? This cancels. 3 to 4 is 12. So at least it is fitting, right?
Yeah.
For n is equal to 2, it is fitting. I can easily find now n is equal to 3 C3, right?
Yeah. Yes.
So if I check for 2 and check for 3, I will be able to confirm this option, right?
Yes. So we'll just do it by confirmation.
And once you confirm this option, then you can take limits of 1 by n Cn and all, right?
Yeah.
Are you understanding?
Yes.
There is nothing very difficult about this problem. It's just you have to keep checking. Be smart about it. If you don't check, you will not be able to do anything. Okay.
Yes.
Also, now suppose we have confirmed it is correct, right? And then what do we do for 1 by c and infinite summation, right? Let's see what happens if 1 by c and infinite summation we are doing for this, right?
Mm-hmm.
So 1 by cn is equal to 2n plus 5 by n plus 1, n plus 2, and there is a 3 power minus n, right? Correct?
Yes.
I have to do summation of n1 to infinity of this, right?
Correct.
So first of all, here you will see n plus 1 plus n plus 2 is 2n plus 3, right?
Yes.
So this is 2n plus 3 plus 2, right?
Yeah.
N plus 1, n plus 2. And then I will split this whole thing into two separate things, right?
Yes.
And you are getting 1 by n plus 1 plus 1 by n plus 2 plus 2 by n plus 1 into n plus 2, right?
Yeah.
And the whole thing is multiplied by 3 power minus n, right?
Yeah.
Correct. And actually, this also can be split, no? So it is 2 into n plus 2 minus n plus 1, right? So this is 2 times 1 by n plus 1 minus 1 by n plus 2, right? 2
Yep.
times 1 by n plus 1 minus 1 by n plus 2. So overall you will get 3 by n plus 1 minus 1 by n plus 2, right?
Yes.
Do you understand? Overall,
Yeah.
this whole thing has been broken into partial fractions like this, right?
Yes.
Okay. So now I need to do the summation, and outside there is a 3 power minus n. Okay. So, so this is becoming like a, this is becoming like if it was an HP and a GP combined, right?
Yeah.
something like that. So separate it out. You have two different summations. One is 1 by n plus 1 into 3 power minus n, minus the other one is 1 by n plus 2 into 3 power minus n, right? Correct?
Yes.
Let's try to do these separately, this one and this one separately, right? So 1 by n plus 1 into 3 power minus n. So sum is equal to, when n is 1, it will be 1 plus 1, 3 power minus 1. Then 1 by 2 plus 1, 3 power minus 1, minus n. So this will be summation over 1 by n plus 1, 3 power minus n. Okay, n will be 2 now, right? Yeah, correct.
Mm.
Are you understanding what I'm trying to do right now?
Yes, yes, yes.
I'm just writing the terms and I'm trying to
Or minus.
see what will we do, right?
Yeah.
So, okay, so maybe the method that we usually use, which is the multiply by common ratio and then shift and all, right?
Yes.
Maybe that method will be useful, maybe not, I don't know yet, but we can say 3 power minus 1 into s, right?
Yes.
That should be equal to 1 by 1 plus 1 into 3 power minus 2, 1 by 2 plus 1 into 3 power minus 3, and so on, right?
Yeah, and then factor.
Okay. But right now, immediately nothing happens if you subtract, no? That's the problem because it's HP, not AP, right?
Yeah.
You understand?
Yes.
What can we do? This is 1 by 3, 1 by 2. This is 1 by 4, 1 by 3. Hmm. This was the thing, no?
Yes.
Overall, this was what we were getting.
Yes.
Hmm. Problem is that there is no easy formula for sum of an HP. So, okay. D option is obvious. Limit of 1 by Cn will tend to 0, right? First, second, and fourth options are clear. It's the third option that is a little bit of a problem, right?
Yeah.
So maybe there is another way to do this. 1 second. We have one by Cn summation is needed. Um, hmm. We have to use the original equation somehow. K is equal to 1 to n, ak, bk, ck is equal to 1 by 3, n plus 1, n plus 2, n plus 3. And we have to find summation k is equal to 1 to infinity, 1 by ck. Uh, hmm. And an was 2n plus 5. Bn was 1 by 3 power n. How do I use this? How do I find this using this somehow? Uh, See, I know the summation of AK, BK, and K is equal to 1 to N. That is an AGP, right? Correct? If I have to do this A1, B1, C1 plus A2, B2, C2, and all, can I say that it is not the same thing as doing, you cannot split it, no? That is the problem.
Yeah.
You can't say that it is summation of CK multiplied by summation of AK, BK. That is different, right?
Hmm.
Is it the same thing? No. You are getting many extra terms here, right?
Yeah.
Because I know this. Okay. Okay, at least I can say one thing, that this summation will be less than equal to this rate. Correct?
Yeah.
That is for sure. No?
Yes. Yes.
Do you understand why? Because there are many extra terms you are getting here, no?
Yeah. Yeah.
Right. So at
Yes.
least we'll be able to get an inequality at least,
Hmm.
right? So but will that help us? No, it doesn't seem like it can help us to get this. Okay, so Cn expression was only available to us. Cn expression was n plus 1, n plus 2 by 2n plus 5 into 3 power n. N plus 1, n plus 2 by 2n plus 5, 2n plus 5 into 3 power n. Okay, an is 2n plus 5 and bn is also given. An into bn into cn is simply n plus 1 into n plus 2, right? Do you understand what I'm saying? This into this, right?
Yeah.
And okay, an into bn into cn is this. So yeah, I don't know. Right now, I'm not getting any nice way to do the summation of 1 by cn. We can simplify 1 by cn and all. We did that, but the problem was it was becoming an HP multiplied by an GP, right?
Yes.
Maybe we can still do it. I just don't see the trick there. 1 by Cn is 3 times n plus 2 minus n plus 1 by 2n plus 5. By, no, not 2n plus 5. That is 2n plus 5. And in the denominator, you have n plus 2, n plus 1. And 1 by 3 power n. Do we have to do like simple telescoping series? 3 by, what is this? 3 by, maybe it is simple telescoping series. Right? 3 by n plus 1 minus, what is this? By n plus 2, right?
I get it. Yeah.
This is Cn, 1 by Cn. So if you write down all the terms, the first term is when n is 1. No, the first term is when n is 2, because this formula was not valid for n is 1, right?
Yes.
We have already found n is 1, right? 24 by 7.
24.
C1 was this. So 1 by C1 would be 7 by 24, right? Now from n is 2 onwards, this formula should be valid, right?
Yes.
So we can say 1 by C2 will be equal to 3 by 3 plus 1 minus 1 by 4, right? 1 by 3 square, right?
Yes.
1 by C3 will be uh, 3 by 4 minus 1 by 5 and 1 by 3, right? 1 by C4 would be 3 by 5 minus 1 by 6 and 1 by 3 power 4 and so on. So nothing immediately looks like it is getting cancelled so much. Okay, some stuff gets handled.
Yeah, I think
1 by C5 is 3 by 6 minus 1 by 7.
consecutive are cancelling.
What?
I think consecutive are cancelling. When you multiply the 3 square, 3 cube inside, then they are cancelling.
So if you multiply it out and write, it will be 1 by 9 minus, this is 1 minus 1 by 4 into 3 square, right?
Yeah, same thing is coming down.
This is coming what? 1 by 4 into 3 square. Oh, wow.
Yeah.
Minus 1 by 5 into 3 cube.
Same thing.
Oh, okay. Thank God. It is becoming telescoping, right?
Yeah.
So all we need, actually, when n tends to infinity, the last term also doesn't matter, right?
Yes.
You understand what I'm saying? Since these are cancelling and n tends to infinity, last term will not matter, right? We don't even need to write that.
Yeah.
The sum of this will be 1 by 9, right?
1 by 9.
Plus 7 by 24, right?
Yes.
1 by 9 plus 7 by 24, if we do, you'll get 48, 72. So it will be 8 plus 21. Right?
Yeah.
So basically, it's a telescoping series. You have to split it. We had already split this, but after that, we didn't think of telescoping. We thought of AGP and all, but that was not working, right?
Yes.
Okay. You start the problem by finding C1, C2, and finding 1, 2, and 4. 1, 2, and 4 are very obvious to find. Okay.
Yes.
The only place you have to think a little is third one.
Yes.
Okay. Okay. Next one, what is it? Tell me.
The 12th one.
Okay. The match the following.
It's not match the following. It's like a grid sort of thing, and they're asking
Okay.
some of.
Yeah. That's great. Yeah. Okay. Okay. So let's look at it's a multiplication table of grid 2019 cross 2019. If the sum of all the numbers inside square ABCD is K, then mark the correct statements. Sum of all the numbers inside the square they are asking us to find, right?
Yes.
Basically, we just have to find this sum, right?
Yeah. Sum.
So what is this sum? It is 1 into, first row is 1 into 2018 CO, 2 into 20. Okay, that's an easy sum, right? Second row is 1 into 2018 C1. Okay. I think you should have been able to do this. I don't think this is hard. I mean, on the face of it, it looks easy. Do you understand what I'm saying? A, B, C, D, right? First row was what? 1 into 2018 C0 and 2 into 2018 C0, right?
Yes.
Till it was 2019 times 2018 C0, right?
Yeah.
2018 C0. Second row was starting with what? 1 only. Okay, all the rows are 1 only and it is going to 2018 C 2018. Everything is same. Yeah.
Yes.
But here it will be 2018 C 2018, right? And 2018 C1 here, like this. And here it will be 2 into every row is same, no?
Yes.
And it will be 2018 C 2018. Okay, this is super easy. Don't add like this, add like this. This is super easy, no? What is this? 2 power 2018 into
Okay,
1.
yes, I realize.
This is 2 into 2 power 2018.
Yes, Navya.
And this is 2019 into 2 power 2018.
Yeah, yeah.
Actually, this is a super easy problem. They are asking you whether you can find the sum like this. Actually, like this also you can find, but that will be longer than what we are doing right this.
Yes, sir. Actually,
And
I didn't even
then hmm,
coming like this.
it didn't even what?
I didn't see that it's becoming like that column wise.
So you
Row wise,
didn't
I got
see it. You didn't see it because you, as soon as you saw the question, you felt like it's weird and all.
yeah, I do.
If you are scared of the question, you will not see the obvious things.
Yes.
That's what I'm saying. Don't get scared of the question. Just because it looks weird doesn't mean it's going to be hard. It might be super easy like this one.
Yes.
Just look at the question with an open mind. If it can be done, you will do it. If it can't be done, you will not do it. See, ultimately, what will happen? You will not be able to solve some question. That doesn't mean some big deal has happened. There are hundreds of thousands of questions that I cannot solve. It's beyond my ability. But whatever is in my ability, I will solve, right?
Yes.
So there's nothing to be scared of a question. You look at it, if you were not scared, you would have seen this pattern. It's so easy, right?
Yeah, it's easy.
Okay. There's nothing to be scared of. You just try it with an open mind. That's the important lesson. So this is a super easy question. You will be able to solve it now yourself, right?
Yes.
What else?
17. That also looks bad, but that is actually not understandable. You know.
Okay. Okay. 17th one. So they are saying SCR basically for non-negative integer. They are defining SCR, right? S choose R. They are defining that and they are saying it is the regular thing. This is valid only if S is greater than equal to R, right?
Yes.
And the other case is 0 if R is greater than S, right?
Yeah.
Okay, so that is just a definition of S choose R. There is nothing weird about it, right?
Yeah.
For positive integers M and N, for positive integers M and N, they are defining a function GMN. GMN is equal to, okay, summation of P goes from 0 to M plus N. Summation of P goes from 0 to M plus N. And on top they have F of M N P by N plus P C P, right?
Yeah.
F of M N P by M plus P C P, right? This is like SCR, this is M plus PCR, CP, right?
Yeah.
And okay, and then they are saying where for any non-negative integer P, FNP is defined, right? Any non-negative integer P, F of MNP is defined as F of MNP is equal to summation I goes from 0 to P, summation I goes from 0 to P, okay, and what is this? MCI N plus I C P and P plus N P minus I. MCI, next one is N plus I C P, N plus I C P, and last one is P plus N C P minus I, right? CP minus I, correct?
Yes.
Okay, great. Now, in this problem, later what are they asking you? They are asking you things like G of Mn is equal to G of Nm and stuff like that, right?
Yes.
They are asking you properties of this function, right?
Yes.
So basically, if we figure out this function, our job is done, right?
Yeah.
Okay. See, again, this is an example of a question which looks scary, but I don't think it is very hard. We'll see. We'll see what it is. So, f of m and p we have to first understand. Okay. So, I goes from 0 to p, and this is, see, mci. So, m factorial, m minus I factorial, right? And then what is there? Should I write it like this? Okay, I'll write it p plus n factorial by p minus I factorial. And this is p plus n minus p plus I. So n plus I factorial, right? I'm breaking apart the first and the third one right now, right?
Yeah.
Do you understand what I've written?
Yes.
And then here, what is it? N plus I factorial by p factorial and n plus I minus p factorial, right? The second one, right?
Yes.
So first of all, I'll cancel n plus I factorial in this,
Yeah.
and n plus I minus p is there and p minus I is there. N plus I minus p and p minus I is here, right?
Yeah.
Correct?
Yes.
And what I can say is this plus this adds to what? Can you see this adds to n? N plus I minus p plus p minus I, right?
Yes.
It adds to n, no?
Yeah. Yeah.
So if I had an n factorial on top, I have to put an n factorial like this down, right?
Yes.
And then I can write this is nc this, right?
Yeah.
Correct, no?
Yes. Yes.
So I will then remove these three and write it as nc p minus I, right?
Okay.
And I have put a 1 by n factorial here, right?
Yeah.
Okay. And now see 1 by n factorial, p factorial, and this can be combined as one thing, right?
Yes. Yes.
P plus ncp,
Yeah.
correct?
Yes.
And you have a mci anyway, right?
Yeah.
Okay. Okay. MCI and this thing. Okay. One second. Okay, the advantage of writing it like this is that at least this doesn't have an I, right? I have I only in these two, right? Correct?
Yes.
Do you understand what I'm saying?
Yeah.
Right now we have rewritten this one as this, right?
Hmm.
So
You can get that out of the summation.
this is outside the summation now, right?
Yeah.
So we can say that p plus n cp comes out of the summation, and we have summation of I goes from 0 to p, n c p minus I and m c I, right?
Yeah.
Okay. Now let's focus our attention on this part, because if we can figure this out, then it will be over almost. So I'll just rub off this stuff a little bit. My f of m and p is coming out right now like this, right?
Yes.
Okay. F of m and p is coming out like this. This summation we have to figure out. Okay. So let's put some values and maybe we'll get a hint, right? Can you see that the top part is fixed here, right?
Yeah.
And the bottom part is like some adding up to P always, right?
Yeah, I remember.
So we get the hint, it's coefficient of P in the product of two series, right? You understand? So I will say 1 plus x power n series, right?
Yeah. C0, C0.
That will be like this.
Yeah.
And I will say x plus 1 power m series, right? I
Yeah.
have reversed it, right? So C naught x power m plus C1 x power m minus 1 and so on till Cm x power 0, right?
Yes.
And let's write the terms a little bit here. Let's write the terms. The terms are NCP minus 0 and MC0, right?
Yeah.
Second term will be what here? NCP minus 1 and MC1, right?
Yeah. Okay.
Do
Now
you
I get.
understand what is happening?
Yeah. 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 It's like product of those two.
If you take product of these two and take coefficient of x power p,
Mm-hmm.
right?
That's.
How will I get a coefficient of x power p? I will take m. No, I will take nc. Here ncp would be coefficient of p, right?
Yeah.
And that I'll multiply with this with power 0, right?
Yes.
ncp x power p with this, right?
Yeah.
Then p minus 1 will be one term before, we will multiply with the previous one,
Yes. Yes.
right?
Yeah.
And the previous one will be mcm minus 1, which is same thing as mc1, right?
Yes.
Are you understanding what is happening?
Yeah.
How did I get this idea that this is coefficient of this in this product and whatnot? Because I noticed that when I do this summation, the top subscript is adding up, right?
Yes.
And the top part is not even changing, no? M plus n is fixed,
Yeah.
right?
Yes.
And also the bottom part, even though the terms are varying, it adds up to P always, right?
Yes.
So then I have a little bit of experience because I have solved some series. I know then when bottom is also adding up, that means you are looking for one particular coefficient, right?
Yeah.
You understand? You would also get this sense, right?
Yeah. Yeah.
You have seen questions like this before, right?
Yeah.
So, so now it is very easy because I can find the coefficient of this very easily. It is coefficient of x power p in 1 plus x power n plus m, right?
Yeah.
So that will be n plus ncp, right? Correct?
Yes.
So my this function is becoming p plus ncp and m plus mcp, right?
Correct.
Correct, no?
Yeah.
Great. So my f of m and p I have already gotten here, right?
Yeah.
Okay. Now I just need to simplify that part now, right?
Yeah. By M.
We will simplify it. We will be able to get it, I think. It's not a difficult problem. It's just a little annoying. You have to rearrange it here and you have to notice this thing that we noticed just now, right?
Yes.
The tricky part was the initial rearrangement that I did, right?
Yes.
Because in the initial, see right now, what is the issue? There are three terms with I, right?
Yes.
When I did the initial rearrangement, I was able to make it two terms in I, right?
Yeah. Correct.
I took the first and the third and I added an n factorial and on bottom and n factorial on top, right?
Yeah.
Because that was making a new NCR something, right?
Correct.
I hope you remember, you have written that down, no?
Yeah. Yeah.
Okay. You understood that what I did, right?
Yes.
Okay. So now I will just put it here. It is n plus PCP m plus ncp divided by m plus pcp, right?
Yes.
So let's just expand it. Here the variable is p, okay? But I will understand what to do only after I do some expansions and maybe figure out what is happening, right? So n plus p factorial by p factorial n factorial, and here it is m plus n factorial by m plus n minus p factorial and p factorial, right?
Yes.
Divided by m plus p factorial by p factorial m factorial, right?
Yes.
Okay. P factorial, one of them gets cancelled. So m factorial will go on top and these two will come on down, right? Okay, so I will just write it here. What we are getting is n plus p factorial m plus n factorial by these three terms come down, right? N factorial, p factorial, and m plus n minus p factorial, right? Okay. And m plus p factorial is here and m factorial goes on top, right?
Yeah.
Correct. That is what we are getting right now. Okay. Is there anything wrong? Nothing is missing, right? N factorial comes down, yeah. P factorial. Correct. That is what we are getting, and we have to sum over P goes from 0 to m plus n, right?
Yeah.
Sum over P. So if it is a sum over P, ideally I want as few terms of P as possible. And I want everything else to come out, right? Anything that does not involve P and all, right?
Yeah.
Do you understand?
Yes, sir. N plus n factorial.
So this stuff can come out right now only, right?
Yeah.
Those don't have P at all, right?
N plus n factorial and m factorial come.
And actually P factorial can't come out. These stuff can come out, right?
Yeah.
So I'm thinking if taking it out will help us or not. Okay. Then you will have, if I take it out, then I will have left with these things, right? N plus P, P. Yeah, I need a N in the denominator to make it N plus P, C, P. And here, okay. Okay, let me just try it. First, I will take these things out by n factorial. And I'm left with summation P goes from 0 to m plus n. I'm left with P plus n factorial by P factorial, m plus n minus P factorial, and m plus P factorial, right?
Yes.
Okay. Okay, so m plus n minus P factorial here and m plus P factorial here. Okay, these two I want to combine, okay? No, from there only I had gotten this, so that doesn't help us much. Because I've taken out this, no? If I bring it in, it will become the same thing as before, right? Doesn't help us. So I want to change the order and all a little bit. M plus n minus P, and I want to combine this and this, okay? Okay? Because that is a different order than what I had taken out, right?
Yes.
So if I want to combine this and this, what should I have on top? When I add these two, the addition is 2m plus n, right?
Yeah.
Correct, no? So I need a 2m plus n factorial on top, right? So I should put a 2m plus n factorial here,
Yeah.
correct?
Yeah.
And notice that that is not affected by p, right?
Yeah. It's not.
So this whole thing now, these three terms will become something, right?
Huh.
It will become 2m plus n cp, right? Cm plus p,
E M plus P.
right? So I will write it here. 2m plus n cm plus p, right? 2m plus n cm plus p, right?
Yeah.
Correct. And now, if I had a n factorial here, it would have been nice, right?
Yes.
I would get a PCN, P plus NCN or P plus NCP, whatever, right?
Yeah.
So I'll bring this inside because taking it outside doesn't help us much, right?
Yes.
Correct.
Yeah.
So this becomes what? P plus N CP, right? Or CN, whatever you want to call it, right?
Yes.
Correct, no?
Yeah. Yeah.
So this becomes P plus N CN, right?
Yes.
Okay, fine. Now I have to think of this summation, right? Because there are two things where P is varying, the rest of the stuff is outside, right?
Yes.
Okay. Okay. So let's think of this summation. I will keep varying P. I will write a few terms and maybe I'll get a sense of what to do then. Right. So I will say P is 0, then it will be NCN and 2m plus NCM, right?
Yeah.
When P is 1, it is N plus 1 CN and 2m plus N C M plus 1, right?
Hmm.
Correct?
Yes.
Okay. Okay. And it is N plus 2 CN and 2m plus N C M plus 2, right?
Yes.
So there is a pattern. Do you understand? There is a pattern.
Yeah.
The difference between the subscript and the top part is m plus n always, right?
Yeah.
Correct, no?
Yeah.
Okay. So we have to basically now figure out how to get this, right?
Yes.
When I do product of series, how can I ensure that I get this, right? And last term also we should write. Last term will be when n goes to p goes to m plus n, right?
Yes.
So it will be p plus so p goes to m plus n. So it will be m plus 2n, right?
Hmm.
So I will not write it like this. I'll write m plus n plus n, c n, right? And it will be 2m plus n c. Here it will be m plus n, right?
Hmm.
Or basically 2m plus n will come here, right?
Yeah.
Are you understanding what I'm doing right now?
Yes.
I'm trying to write the product of these series like this term by term, right?
Yeah. Yeah.
Okay, so first obvious series is 1 plus x power 2m plus n, right?
Yeah.
So let's write that series 1 plus x power 2m plus n. That series is c0 plus c1x plus c2x square and all. But the main terms for us start after x power m, right?
Yeah.
Correct. So it will be 2m plus n c m x power m and then 2m plus n c m plus 1 x power m plus 1, right?
Correct.
And say so on still 2m plus n c 2m plus n x power 2m plus n, right?
Yes.
Correct.
Yeah.
The other series, if you see here ncn, this is n plus 1 cn, the values on top are increasing, right?
Yeah.
and it is going up to this. So it is like saying n plus 1 c. The other series is not very nice because the top powers are changing, right?
Yes.
Uh, Here the powers were x were increasing like this, and we needed these terms, right?
Yes.
Okay, okay. Uh, how do I get it? This is n plus 1 c1, n plus 2 c2, n plus 3 c3, you know. Hmm. Yeah. Okay. I have 1 plus x power n. It's always 1 plus x power n plus 1, 1 plus x power n plus 2, till 1 plus x power m plus 2m, right? In all these series, coefficient of x power n, right? Here it is ncn. Here it is n plus 1 cn, right? Here it is n plus 2 cn. And here it is m plus 2n cn, right?
Yes.
Correct, no?
Yeah.
And I'm multiplying coefficient of x power n, x power m plus 1, m plus 1 plus n. The powers are changing. That is the issue. Okay, so hmm, hmm. It is almost done. We are just missing one final step. Right now, like this, it will be difficult to sum up. No, the powers are changing. No,
Yeah.
so obviously this won't work. So we will write here g of mn had come out to be m plus n factorial m factorial by 2m plus n factorial summation p goes from 0 to m plus n p plus n c n and 2m plus n c m plus p, right? This was what was our expression. Hmm. I feel like I have made some mistake in grouping and all. We should not group like this. Do you remember the earlier expression when we had just replaced f of m and p and all? Have you written down that part? You remember what you understand what I'm asking? F of m and p divided by n plus p cp was there, right?
Yes.
Uh, 1 second. And the summation was over P to M plus N. P is equal to 0 to M plus N. So what was the expression for f of M and P?
I didn't write it, sir.
Why haven't you written that?
Right.
How will you understand the question later?
I will write that down so once the entire solution like it comes. I was like in progress.
There are so many screens that have happened since that. Now, how will you write it down later? Like, why are you not making notes of what we are discussing? I don't understand. If you don't write important results, then what's the point?
I wrote till the last question. I just didn't write this.
P plus NCP, this is the expression M plus NCP and M plus PCP. I have to combine these two. I have m plus 2m plus n factorial I need on top. I'll put on down also. And this and this and this become subscript is changing. That's fine. I don't want P on top. That's the only issue. We are left with this term, this term, this term, this term, this term. We're not sure. We'll have to think about it. I'll see if I can get it later. Right now, the last simplification is not happening. Only if we can find g of mn, we can answer the rest of the stuff. The last part simplification is not happening. We'll have to think about it. I'll try it later and let you know. What else is it out in this sheet?
I didn't try further.
Huh?
I didn't do further, so that's it. I'll try and do.
Okay. Fine, we'll continue in the next class then for physics, whatever doubts you have.
Yes.
Fine, that's all for now then.